So it's a layer 3 in the OSI model. This layer is known as a network layer. Whenever we are talking about a layer 3, there are devices which are based on the various layers of the data link layer, of the OSI model. At present, we are utilizing TCP/IP model, but still the concept that are associated with the OSI model, the layers that are suggested in the OSI model, we will study the different concepts about the network layer for the OSI model as well as the IP layer in the TCP/IP model. Important functions that are supported at the network layer basically are the addressing and managing the network. The concept of addressing was introduced at the data link layer itself. It was the physical address. We have already seen there are 4 different types of addresses that are utilized in the data networking. Physical addressing, then virtual addressing, which we are utilizing as a IP addresses, then port addressing, and the application addressing. Application addressing, specific application is utilizing a specific configuration, and that is the application addressing, which utilizes different socket type of connectivity at the application layer. But at present we'll concentrate on our network layer. The network layer actually takes the responsibility of routing the packet from source to destination within or outside a subnetwork. We have seen the hopping of the packet from one point to another point. Whenever 2 different computers either connected in a subnet, the computers which are connected in the subnet, we call it as the computers of local area network. But it's not that one of the computer from one subnet may be communicating with one of the computer from other subnet. So 2 different subnet, these 2 different subnet we have seen may have different type of addressing schemes, may have different type of topology, or the addressing scheme of one will not at all be compatible with the addressing scheme of the other. Same is with the protocol. 2 different subnet may be operating with the different type of protocols which are not at all compatible with one particular layer. The network layer has the responsibility to route this particular packet from source to destination, mapping different addressing schemes and protocol. Mapping different addressing schemes and protocol just to route the packet. At the data link layer, we have seen that it's the transmission of frame from sender to the receiver and acknowledgement associated with that particular frame. But the network layer has the responsibility to route the packet from source to destination, and in between mapping different types of addressing schemes and protocols. At the source layer, addressing scheme may be different. At the destination level, addressing scheme may be different. The protocol that is utilized at the source may be different, but it's the translation of, instead of frame, it's the translation of packet from one host to another. That is, host to host packet delivery is the important function at the network layer. There are various tasks which are actually supported at the network layer. One of the tasks we have already seen in the initial lectures, addressing the devices and networks, then providing the routing tables or providing a static path, static communication path. Then the functions of the network layer, it properly receives the incoming and properly queues the outgoing data and then forward it according to the quality of service constraints, QoS constraints, for the specified packet. The QoS constraints may be different for different packets. We have seen hopping of one packet from one point to another point. The internetworking between 2 different subnets is again one of the important functionalities supported at the layer 3. Then the packets from destination towards destination with best possible efforts, with best possible mechanisms, with best possible connectivity. And this particular best possible connectivity has given rise to two different concepts at the network layer, and that is connection oriented connectivity and connection less type of connectivity. The connection oriented connectivity and connection less type of connectivity, we'll see the details associated with this connection oriented and connectionless. But again, along with the functionalities, the features that are supported at the network layer are, it actually provides a proper link management within a subnet, as well as proper load balancing in between the source and destination. Then interrelation of the different protocols. Just now I have told you interrelation of the different protocols within the different schema. At the source end, it may be the star type of topology. At the receiving end, it may be a bus type of topology. But the packet will, if it's for a specified destination, it will be delivered to that specified destination. That is the important function. And that includes various types of network designs. These network designs are nothing but the features that are supported at the network layer. Practically, we are utilizing the TCP/IP protocol. In the TCP/IP protocol, IP protocol is widely utilized nowadays, widely utilized, and which helps to communicate end-to-end devices over the internet, over the network of network. That is the functioning that is supported by the IT protocol. There are two different versions that we are utilizing nowadays, and still we are more familiar with IP version 4, which is ruling the world from the decades. But actually, somehow IP version 4, which is defining the addressing scheme, which is running out of the addresses, number of addresses, and that's why new standard associated with the internet protocol is suggested, and which is fastly replacing actually the IP version 4. That particular version is IP version 6, which minimizes all the limitations that are associated with IP version 4. There are a lot of configurations that are supported at the network layer. The network layer 3 switches, layer 3 routers, layer 3 concentrators. These are the various types of devices. But basically, the network address is always a logical address, or it's a virtual address. It's not at all a fixed address. You can change this virtual address. In case of physical address, you cannot change the physical address. But in case of the virtual address or the logical address, you can change or you can configure the addressing, and that is the beauty that is associated with the network layer. The network addresses are always configured on the network interfacing card. The network interfacing card, in previous lectures we have seen that it has a physical address. It has a physical address. The Ethernet card that we have seen in the previous lectures, it has a 48-bit address. It's a MAC address. This particular MAC address is to be mapped with the network address, and this particular functionality is supported at this particular our unit 5. The syllabus consists of network addresses. The syllabus, computer communication network. Our topics includes the network layer design, logical addressing, address mapping, error reporting and multicasting, and delivery forwarding and routing. We'll go to these particular concepts. Yes, these are the contents. In the chat box, you can see the network layer design issue, logical addressing, address mapping, error reporting and multicasting, delivery forwarding, and routing. These are the important functions that we will be studying in our unit 5. The unit 5, the design concept. Just now we have seen what is actually required at the network layer, what different configurations are suitable, what are the design constraints that we have seen just now. The important functionalities addressing, that means designing of the addresses. Then routing, that means designing of a popular routing protocol or defining the static routes. Then designing of a proper queuing mechanism for sending as well as receiving. Then designing a proper internetworking function. Then delivering packets to the destination with, I have told you, with maximum efforts. With maximum efforts. So the important designing will be related to the addressing. Then second will be related to the packetizing. In case of data link layer, we have seen that it's a frame. But in case of the network layer, it's the packet. So the packetizing is one of the important design issue. The network layer converts the packets from its upper layer, that is from the transport layer. It takes the information and converts it into the different packets and routes those packets. So routing is again an important functionality, important design issue. The network layer chooses the most relevant and best path. Most relevant, just see the most relevant and best path for data transmission from source to destination. It's a property of packet switching. In case of circuit switching, a proper copper path is established between source and destination. The best example that we have seen a telephone network. But in case of the network layer, it actually chooses the most relevant and most or the best path. The best path includes the efficiency associated with the communication path. The best path includes the auditing facility, that is the cost of the communication should be also less. There is always a trade-off between the cost of the communication and the quality of service, but the optimum quality of service and the lowest destination path or searching of the lowest destination path, these are the important design issues. And hopping from one node to another node, that is internetworking. It delivers the packet with establishing a suitable logical connection across the multiple devices. Now it's the network of network, millions, trillions of computers, trillions of host devices are added. So delivering the packet through these trillions of data hosts and implementing a logical connection, with either the datagram or the virtual circuit, the two different configurations that are supported at the network layer. The important network layer issues, then whenever we are internetworking, it will be store and forwarding the packet. The typical example can be your email services. You are creating a mail and you are sending that mail to a mail server. Then mail server stores the packets that are associated with your email and delivers to the destination. The destination user can see the packet only if the destination user logs in into the system. The Gmail, you are getting the information nowadays on the mobile system, you are getting the indications, but it's basically a store and forward type of packet switching. Store and forward type of, previously we were utilizing Telegram. If you recall the Telegram concept, have you heard about this particular Telegram? Anyone can turn on the mic and give me the information associated with the Telegram. Have you heard of the Telegram? Now In this year only, the telegram facility from the postal department was closed. But right from the Morse code that was initially started as the first communication, the telegram facility was available. And the basic idea behind the telegram facility is typically, we can say that it's a store and forward type of packet exchange. In case of telegram, anyone can tell me the concept of telegram? Have you heard about telegram? Anyone can switch on. Okay. Akanksha, have you heard about telegram? Aniruddha? Yes, Aniruddha, have you heard about telegram?
No, sir.
Oh, तार पाठवायचे आपण आधी तार
हा सर.
माहितीये का काय आहे काय 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 पाठवायचो पण तार म्हणजे काय?
एक्झॅक्टली माहित नाही पण म्हणजे काही मेसेजेस जर फास्ट स्पीडनं पाठवायचे असतील तर पत्रांच्या ऐवजी तार पाठवायचे एवढंच माहिती.
We were utilizing the facilities of our postal system and teletypewriting with the support of the intercommunication between the various post offices. We were sending the message. It's the message forwarding from one point to another point. It's the message forwarding according to the requirement, but that was not in always not in the real time. So message was composed from the person. The person was approaching the telephone exchange. At the telephone exchange, the message was composed and that was sent to the specified destination. That concept is you are storing the message and forwarding to the specified destination. Then at the receiving end, if the teletypewriter is on, then that message was automatically printed at the destination end. And based on the delivery address, that particular telegram, that particular instant message was delivered by the postman at the destination. That was a classical example of store and forward packet messaging. And we are utilizing the same concept still in our email. Email, we are utilizing store and forward. It's not always in real time. Nowadays, there are notifications, there are facilities, but still the email can be worked in the offline mode, not always in the real time mode. And that's why still we are calling the electronic mail system as store and forward packet exchanging. And that is one of the functioning that is supported at the network layer. Store and forward packet switching. The host sends the packet to the nearest router. The nearest router sends the packet to the adjacent router, which finds the path towards the destination. The packet is stored until the proper destination path is fully processed. And by verifying that particular path, the packet is forwarded to the nearby router. This particular mechanism is typically a store and forward packet switching. Another important task is adjacent to the transport layer. So at the source end, take the information, take the packets from the transport layer and then translates those packets and hand it over to the data link layer. So at the receiving end, from the data link layer, align all those frames, form the packets, check all the packets are receiving or available at the receiving end or not, and then hand it over to the upper layer. That's typically the services provided to the transport layer. So the design constraints include addressing, packetizing, routing, and internetworking. These are the four important design issues. We'll see the typical concepts associated with the addressing, routing, packetizing. I will be referring again Furson's book. The Furson's book provides us the complete idea. So the network layer design issues. The network layer design issues, packetizing. Packetizing is very, very, very important. Packetizing, properly providing addressing, inter-network functioning. These are all the network layer design issues. Logical addressing. The logical addressing. What is this particular logical addressing? We'll talk directly with the IP version 4. This particular IP version 4 address is a 32-bit address. This 32-bit address associated with the network provides us the configuration for the specified terminal. This IP address, internet protocol address, we are directly coming to the TCP IP configuration. The IP version 4 address, which is a 32-bit address. In case of physical address, we have seen the 48-bit MAC address. But this 32-bit address is universally defining the connection of a device to the internet. That is, whenever you are connecting your device to the in-between switch or hub with the support of your wired or wireless protocol, that means you are providing the physical addressing along with the logical addressing in the form of IP version 4 address. The physical addressing that was supported was the 48-bit addressing, and the IP version 4 address that we are utilizing, this particular IP version 4 address that we are utilizing from the TCP IP configuration. This particular TCP IP configuration helps us in defining one specific address which will be again unique in that either a subnet or a bignet. Bignet, that is connectivity that is provided from one network to another network, but this will be again a unique type of address. Whenever we are transmitting, we need at least some sort of global addressing. This particular global addressing we are actually defining in the IP version 4, which is the protocol that we are utilizing at network layer in TCP IP configuration. Instead of going for the facilities that are provided for the network layer in the OSI model, we'll go directly to the IP version 4. This logical addressing scheme is also known as a IP address, IP version 4 address that we are utilizing. The internet address, or it can be called as the internet protocol address, not internet address, the internet protocol address. This length is 32-bit. That means maximum 2 raised to 32 addresses can be defined. 2 raised to 32 addresses, it's again a million or a trillion addresses. Whenever we talk in terms of our Indian quantity, it's around एक abj. एक abj. See the quantity, the number of addresses. It's more than एक abj, the addresses, but still they are not at all sufficient. They are not at all sufficient. 2 raised to 32. 32-bit is the length of the address. 32-bit is the length of the address. It's a IP address. So there is no confusion at all. Whenever there is IP address, it will be a 32-bit address. It will be a 32-bit address which defines the connection of a device to the internet. Make it very, very clear. Which defines the connection of a device to the internet. Here we are actually considering two raised to 32-bit addresses, 2 raised to 32-bit addresses, which are unique and universal, In case of public domain, we have 2 raised to 32 IP version 4 addresses. There are no duplicate addresses. How these are formatted, how these are assigned, that we are going to see. This IP version 4, the IP, these, but remember that these are unique and universal. There is no duplicate public domain IP version 4 address that is available. Two devices will never have same address at the same instant of time. At different instant of time, if there are different types of protocols, if there are different types of consequences, then only we will have the same address. But universally, there will not at all be a duplicate address. It will be a unique address. And with the help of some sort of strategies, we may assign this address to a device. At one instant of, but remember again and again I am telling you, at one instant of time, the IP version 4 address will be a unique and universal address. At same instant of time, again and again, at same instant of time. See the address space of IP version 4. It's the length of the IP address is 32-bit. So 2 raised to 32, or 4 Arab, more than 4 Arab IP addresses are available. See the huge quantity, and still we are striving. That means every device that is connected to the internet is allocated one specific IP address at one instant of time. That particular IP address will be a unique IP address that will be assigned to that particular system. And once that IP address is allocated to a network interfacing card which is having a specified physical address, then your terminal is part of the network and all sorts of data can be exchanged with the support of this particular. And that is the importance that is associated with this allocation of the IP address, and the version that we are utilizing is IP version 4. How this particular IP address is allocated? The typical type of notation is known as a dotted decimal notation, and it's very difficult to remember this dotted decimal notification or notation, but still it's again very difficult to remember a 32-bit address which consists of ones and zeros. So instead of remembering the IP address in the ones and zeros, it was thought that we will assign a dotted decimal notation. The dotted decimal notation, that is this particular, see this particular first quantity. See here, 8421, that is 1, 2, 4, 8. Here it will be 1, 2, 4, 8, then 16, then 32, then 64, then 128. So this particular bit, 4 8 bits, first 8 bit, second 8 bit, 4, and forms actually the 32. These 32 bits. Out of these 32 bits, first 8 bits are represented in this dotted decimal form. So it's the decimal form, 100000000. It's The decimal value is 128. For this particular, say here 8421. 4 is 0. 8, 2, 1. 8 plus 2 plus 1, that is 11. That's why second is 11. Then it's 4, 8, 4, 2, 1. 2, 1. That means it's 3. 2 plus 1, that is 3. So it's 3. Then it's 8, 4, 2, 1. 16. So 16 plus 8, 24 plus 4, 28 plus 2, 30 plus 1. That is 31. So this is how we are actually representing the dotted decimal formation associated with IP version 4 address. Once again, I will tell you the dotted decimal formation. The dotted, I will take another example. Suppose I am having the dotted decimal representation as 1.1.1.1. So it will be 0 0 0 0 0 0 1. It will be first 8 bits, then next 8 bits will be again 0 0 0 0 0 1, 7 zeros and then 1, 7 zeros and then 1. Here it will be again 7 zeros and 1, again 7 zeros and 1, again 7 zeros and 1. That will be represented as a dotted decimal configuration or dotted decimal notation for the binary addresses in the IP version 4. Make this particular concept clear here only. Another example I will take, say for simplicity, I will take 2.13.4.8. Just represent this 2.13.4.8 in a binary form. Make your concept here clear. Put your answers in the chat box. Okay, I will give two examples. First is, just put 100.100.100.100. This is the IP version 4 address. Transfer it to the binary form and put your answer in the chat box. That is one example. Then next is 200.200.100.100. This is your second IP address. Second IP address in the IP version 4. Represent it in the binary form. Just give me the answer in the chat box. We'll wait for 2 minutes. It's quite simple. Dotted decimal representation for the IP version 4. We are defining somewhat, it's quite simpler. It may be the IP address may be in the range all 1111, then 00, then last one will be 11. This will be the starting 8 bits. Second 8 bits may be 1100, 1100. Third 8 bits may be all zeros. Fourth 8 bits may be all ones. 4 8 bits may be all ones. What will be the value for all ones? Dotted decimal value for all ones. Just anyone tell me the dotted decimal value of all ones. Instead of all zeros, see here. Say this particular. It will be 1 1 1 1 1 1 1 1. Just calculate its dotted decimal value. Correct. 255.255.255.255. That is the maximum value or maximum value of a IP address in the IP version 4 notation scheme. It will never exceed 255 because of the binary notation represented in a dotted decimal format. And that's why it's a specified type of standardization that was done to represent the binary digits in the form of dotted decimal. If this particular concept is quite clear, then we can go for the various configurations. Just see this particular example. Change the following IP version 4 addresses from binary notation to the dotted decimal. Check it. Convert the binary data into its dotted decimal. Only 8 bits are to be converted. Only 8 bits are to be converted into the dotted decimal. Each group of 8 bits are converted to its equivalent decimal number, and we are adding a dot after the decimal conversion. It's quite simple, just a binary calculation and binary to dotted decimal representation of IP version 4. The second example is related to the translation of IP version 4 address from dotted decimal notation to the binary notation. 111. 111 representation is 011, 011, 11. 111 is the dotted decimal representation. Convert it into the binary notation. 56. Binary representation is 00111 For 45, it's 00101101. For 78, it's binary representation, binary equivalent. You can say binary equivalent 01001110. That will be the conversion of dotted decimal to binary notation from binary. But see here, it's very difficult to remember this 32-bit address. Instead of remembering the binary version, it's also not quite easy to remember the dotted decimal, but we can remember this dotted decimal compared to the binary representation. And that's why it was the 32-bit addresses were represented in a dotted decimal format. If you have only 10 numbers, say only 5 terminals in your entire local area network, then it's quite easy to remember 5 different dotted decimal notations associated with the IP address compared to still the 5 different 32-bit addresses. And that's why the dotted decimal representation was standardized for IP version 4. Find the error, if any, in the following IP version 4 addresses. The first address 111.56.045.78. There must not be a leading zero. Leading zero is never a dotted decimal representation. Then second one 221.34.7.8.20. It's only 4 dotted decimal representation. So second is also not worthy. Then third one is 75.45.301.14. 301 will never exist. The maximum number for the dotted decimal representation will be 255. Then intermixing of binary and dotted decimal is not also allowed. So there must not be a leading zero. for any dotted decimal representation. There cannot be more than 5 dotted decimal numbers separated by dot. Each number in the dotted decimal representation will be always less than 255. Why this 255? We have seen that assigning all ones will lead to 255, and mixture of binary and dotted decimal is also not at all allowed. This particular configuration gave rise to the address space configuration, the specified binary and dotted decimal representation, and assigning the configurations. Still, there are, see, we have seen that 2 raised to 32 IP addresses are. So, in order to provide a proper standardization, one particular representation was suggested in the IP version 4 standard, and that suggestion gave rise to the two different configurations. Okay, is there any doubt associated with dotted decimal representation of the IP version 4? You can unmute your mic. I think the concept is quite simple one, but it's better here only, because this particular dotted decimal representation is the IP address that is universally utilized nowadays on internet, which will help us in creating a socket. So all sort of web programming, all sort of socket programming, this particular basic concept needs to be very clear. In order to provide a proper configuration associated with these huge number of IP addresses that are available, the two different types of addressing were suggested in IP version 4. The first type is known as a classful addressing. In this particular classful addressing, the address space, all these address space, 2 raised to 32 addresses are divided into 5 different classes. These 5 different classes are typically known as A, B, C, D, and E type of classes. These are the class of an addresses. If the address is specified in the binary notation, and falls within the specified range, then this actually are the addresses belongs to this particular class, and that's known as a classful type of addressing. What that we will see actually. Before that, I take it for granted that there is no difficulty in understanding the concept of dotted decimal and the digital addressing. See, these are the dotted decimal representations and binary notation. Binary notation. 5 different classes. In case of, say, we'll start with the binary notation. If the IP address start with 0 for the first byte of 4 different bytes, then it's a class A type of address. Make this particular concept very, very clear, where the first byte starts with 0, the class of that address is class A. In the dotted decimal representation, all the IP addresses which starts with 0 or which starts with 127, starts with 0 up to 127, that is the range of the class A type of IP addresses. Whenever the binary notation starts with 10, the equivalent dotted decimal representation will be from 128 to 191. Whenever the binary first 8 bits, from the first 8 bits, if 110 are the first 3 bits, then that is a class C type of IP address. So the ranges are 192 to 223. For example, say 0.0.0.0, it will be a class A type of address. 0.1.1.1, it will be a class A type of address. 127.0.0.0, it will be a class A type of address. Class B type of address will be 128.0.0.0 to 191.255.255.255. Any address within this particular range. Say for class A, it will be 0.0.0.0 to 127.255.250, or instead of 255, we'll consider the nearest value 254.254.254. So that will be the range of IP addresses in a classful classification for class A. For the class D configuration, if first 4 bits are 1110, then it's a class D type of IP addressing scheme. If first 4 bits starts with 1111, then it defines class E. So the ranges for class E will be 240.0.0.0 to 240.255.255.255. This is known as a classful type of addressing. The classes and the number of blocks. We will see the classes and number of blocks. Just we'll see these 2 examples. See here, find the class of the first. It starts with 0. If it starts with 1, then it will be a different. But if it starts with 0, this is a class A type of address. Then if it starts with 110, it's a binary representation. For binary representation, 0, 110, 110, the first 2 bits are 1. The first 2 bits are 1, that means it's a class C type of address. Then the dotted decimal representation, 14.23.120.8. The first one I have told you, the first one, the range starts with 14. So 14 falls in the class A ranges 0 to 127. 0 to 127 is the range of class A addresses. 14 falls in that. So it's a class A type of address. When the first byte is 252, dotted decimal representation. It's a dotted decimal 252. For class C, it starts from 242 to 55. So 252 falls in 242 to 255. That's why it's a class E type of scheme. 255.5. Forget about the last three notations or last three bytes. Concentrate on, if it's the binary representation, the first 4 bits. If it starts with 0, it's always a class A. In the dotted decimal, if it falls in the range of 0 to 127, then it's always a class A. If IP address starts with 128 to 191, it's a class B. If the IP address starts with 192 to 223, then it's a class C. Then from 224 to 239, it's a class D. From 240 to 255, it's a, if this dotted decimal representation, then it's a class E type of dotted decimal representation. The number of blocks and block size in the class full IP4 addressing. Based on these particular classes, some applications associated with the host terminal. It's not that always this particular application will be followed by the specified client, but in the standard, it's always suggested. So in the class A type of configuration, there will be 128 block, and the total block size will be 16777,216. Typically, it's reserved specifically for the applications such as the unicast type of application. But it's not always. Just now, forget about this last block. Previously, it was suggested. But nowadays, any type of IP address can be utilized as a unicast or a multicast type of IP address. The number of blocks in the D and E provides us the block size of 268,435,456, so that these particular block size addresses are available for multicast. That's the meaning. But though it was initially suggested for providing a simplicity, previously whenever a block organization was requesting a block of addresses, it was granted either in A, B or C. Class A addresses were specifically provided for the large organizations with a large number of attached hosts or the computers or the routers. Class B addresses were designed for mid-size of organization with tens of thousands of the attached hosts. Previously, first one is the largest one, Class A. Class C addresses are designed for a small organization with a small number of attached hosts or routers. So the maximum number of hosts or routers that are available in the Class C, depending on the block size, will be only 256. Will be only 256 one for one particular range of IP addresses. What is that? We will see. Just at this particular, just remember the classful IP4 addressing blocks and the typical application. At present, all the IP addresses can provide all types of applications. In the class full addressing, a large part of the available addresses were wasted. That's the drawback. A block in a class A address is too large for any organization. The organization may consist of all, say 1,000 terminal, 5,000 terminals, say 10,000 terminals. Globally, if you see the manpower associated with Google, it's not more than 1 lakh or say 10 lakh. So if a block of IP addresses are assigned to the Google, in a public domain, more than 1 lakh addresses, all those addresses will be wasted. And that is the important drawback associated with this particular classful addressing scheme. A large part of available addresses were wasted. So one particular concept was introduced, the internet authorities, the prediction for the internet authorities was a specific group of say 268,435,456, the number of hosts that are available in the class A. But it was never happening. Here, majority are wasted. Previously, whenever we standardized IP version 4 in case of class E, all the class E addresses were specifically reserved for future use. So only few were only allocated, and no one was allocated the IP addresses in the range of E, and that's why there is a shortage. Even though if we can say that 2 raised to 32 are the configurations, 2 raised to 32 addresses can be assigned in IP version 4, but practically it's not at all the case. Very large number of addresses are wasted in class A. Only few addresses were wasted in class C, but the number of blocks that are available in class C are only 256. So the number of class IP addresses wastage are less, but still some IP addresses are wasted. In case of block A, class B, majority of the IP addresses are wasted. Previously, there were dominant companies, say Intel. Intel was dominant and purchased majority of the class A addresses, but utilized only 5,000 or 10,000. Purchased millions, but only utilized 5 or 10,000. Remaining are purchased by the Intel, so no one can utilize those addresses. I'm giving just an example of Intel. There are large organizations which were initially providing the funding for the standardization of the IP version 4 and immediately purchased the classes of the IP addresses. That was one of the major drawback for IP version 4 type of addressing. And some other concepts were utilized in the class of addresses. These schemes are typically known as how actually the IP addresses are assigned with a specified subnet mask. A specified subnet mask. So whenever we are representing class A type of class B or class C, in case of class A, the subnet mask that is supported for a classless inter-domain routing, which is presented in the dotted decimal format, is 255.0.0.0. So it will be a classless inter-domain routing, CIDR, supported for class A, which will be provided with a mask. A mask is provided, that means all these IP addresses, all these bits will be always masked, which will not at all be allocated to any other terminal. The net ID, the concept of net ID and host ID was utilized in the classful addressing scheme. The IP addresses in the class A, B, and C are divided into this net ID and host ID, having a variable length, depending on the class of the addresses. The some net ID and host ID I will show you next. Not at all actually. Okay, just remember that the for a class A type, 1 byte defines the net ID and remaining 3 bytes defines the host ID. In case of class B, first 2 bytes defines the net ID and the remaining 2 bytes define the host ID. In case of class C, first 3 bytes actually defines the network ID and only 1 byte defines the host ID. So whenever I am taking 192.68.1.0.1, so 192.168.0 will represent the network identification or network ID, and the last bit ranging from 0 to 255 will define the host ID. So the host ID in a specified network will be, say for class C, will be 192.168.0.12.0.254. 255 is being again a part of the dotted decimal representation. So maximum number of addresses that can be utilized in a class C with net ID and host ID will be only 254. Another example I will give you in the class C only. Say if it's 192.168.100.0. So the first 3 bits 192.168.100 will represent the host ID and will represent the network ID, net ID, and only last byte whose dotted decimal representation varies from 0 to 254 will be the host ID. So the host IDs in case of class C will be varied for the variation of last 1 byte. For example, another example 192.168.10.0, 192.168.10.254. So from 10.0 to from 10.254 will be the IP addresses that can be allocated to the class C type of network who can communicate with each other without any problem, and that gave us the idea of grouping of the terminals based on the IP addresses. So for a small group of terminals, say 256, if the IP addresses that are used in the class C type of configuration, first 3 bytes will remain the same. And that's what configuration we are typically utilizing if our number of terminals in a specified organization are less than 255. And that's why class C type of IP address allocation scheme is very popular in India, where we are utilizing the first 3 bytes defines the network ID and the last byte actually defines the host ID. Host ID can be your ID that is assigned to your mobile, ID that is assigned to your PC, ID that is assigned to a network printer connected in class C configuration. The length of the net ID and host ID are fixed specifically by defining actually the configuration, the first byte, last 3 bytes, the first 2 bytes, last 2 bytes. That is for class B. First 3 bytes for class C. Class C. The classful addressing scheme, actually this particular classful addressing scheme was properly standardized with the help of this particular subnet mask. And this particular subnet mask, say for class A, we always allocate this subnet mask as 255.0.0.0. So the host can take any ID from 0.0.0 to 254.254.254. That is the range of host IDs for class A by defining the subnet mask as 255.0.0.0. I think this particular concept is somewhat tricky, but quite an easy concept. And this has helped in defining a group of computers having a specified network ID and host ID. And this, whenever utilizing, we are actually creating subnetting, creating a subnet. Whenever all the terminals in our computer lab are assigned the IP addresses in the range 192.168.1.1 to 1.30, all these computers are actually forming a subnet. This is the concept of subnet in the classful addressing. If a large A block of A, class A or class B is allocated, it could divide into the number of addresses, various various groups with small networks. But those will be the subnet for classful A addressing or class A addressing scheme or class B addressing scheme. This is typically known as the subnetting. Subnetting formation of a small group. But there were the stages where majority of the companies blocked the IP addresses in class A and class B. But there was still a huge demand. That was the first bubble of .com. .com was a specific .com was assigned to the IP address. So abcd.com will be translated to a specified IP address, that will be a virtual address, application address, virtual address, then MAC address. So that particular bubble was a huge bubble for the demand of large blocks of IP addresses. The class C was not at all able to satisfy most of the organization. And that's why one concept was added, and that particular concept was typically known as a supernetting. So supernetting is the combining various class C type of addresses, that is, one subnet will have 192.168.1.0. The subnet may consist of 255 computers. So the last IP address will be 192.168.1.254. That will be a group of computer. Then in the same organization, another range of class C IP addresses were assigned, 192.168.2.0 to 2.255. And this particular configuration is known as supernetting. So in order to utilize the advantages that are associated with IP address allocation in the class C, specified class C can be supernetted with huge number of blocks that can be utilized. But in one particular subnet, not more than 254 computers can be connected. That was one of the drawback. And this particular is due to the address depletion, the concept of address depletion. And this concept of address depletion actually gave rise to the demolition of the classful addressing scheme, that gave rise to the classless type of addressing scheme. So in a one particular organization, there will be one public address and there will be large number of private addresses which can utilize any class of networks. And this is typically known as the address depletion, specifically for class A, class B and class C type of blocks. And that's why it's a classless type of addressing that we can utilize in our organization. But again, that particular classless configuration should be properly addressed. All the addresses cannot be utilized in the public domain. So classless addressing was specifically utilized to overcome the address depletion and give more organizations access to the internet. Unless and until you are allocated with a public domain IP address, you are not at all part of the internet. And that's why classless addressing was designed. These address blocks must be of a power of 248. So the next screen will show you this particular concept. Class 2 replaced with classless addressing. See here. The 16 addresses, a block of 16 addresses granted to a small organization. First address is 205.16.37.32. The last address is 205.16.37.47. That 32, 33, 34, 35, 36. That is the dotted decimal representation. So these 16 addresses are allocated to this small organization having a specified binary representation. The typical configuration in IP version 4 can be x.y.z.t/n, where x.y.z.t defines one of the address and /n actually defines the mask. The mask character will be /8. /8, if it's /8, then it's the class A subnet mask, that is 255.0.0.0. If it's the class B, the subnet mask will be 255.255. Remaining all bits are masked, that is the meaning. You cannot allocate the masked dotted decimal address. That is the meaning. But in classless, nowadays it's a classless type of configuration. So the mask, variable mask can be assigned, but the variable mask can be assigned only to the specified class of addresses. That is 190, suppose it's 172.16.0.1. 172 falls in class B. So the subnet mask will be 255.255.0.0. That is the concept of subnet mask, addressing. Okay. See this particular, a block of addresses is granted to a small organizations. We know that one of the addresses is 205.16.37.39/28. What is the first address in the block? Just represent the binary representation. If we set 32 minus 28, rightmost bits to 0. That is last 4 bits to 0. Last 4 bits. Then it's 205.16.37.32. So 32 will be the starting block, first address of the IP address scheme from the 16 addresses. The last address in the block can be found by setting the rightmost 32 minus n bits to ones. Instead of 0, set it all to ones. So that will give you the last address in the block. Here, last 001001111. So change it to last 4 bits 1111. Make it very clear. So it will be 205.16.37.47. So that will be the last address of the block. 32 minus 28. If we set all last 4 bits to 0 and then again calculate, that will be the first. If last 4 bits are set to 1, that will be the last address. That will be the last address. I think this particular concept, number of addresses in the block, can be found by using the formula 2 raised to 32 minus n. Value of n is 28. That means 2 raised to 32 minus 28. It will be 16. If it's 30, then If n is 30, then it will be 2 raised to 32 minus 30. That is 2 raised to 2. That will be the maximum number of addresses in that particular block will be only 4. If n is 1, then 2 raised to 32 minus 1, that is 2 raised to 31, will be the addresses that will be available. To find the first and last addresses, when we are writing a program, in case of the software, this is another representation. 28 ones and 4 zeros. Find the first address, the last address, and the number of addresses. Use this particular mask. The first address can be found by adding the given address with the mask. Adding here is done by bit. So 1 0, it's 0. If it's 1 1, then it's 1. If it's 0 1, it's again 0. So the first address is found out if one particular address is given to you and a mask is given, and the mask bit by bit with the address, that will give you the first address. And if you OR the mask with the complement of the mask, ORing the mask with the complement of the mask, that is, if it's 255.255.255.000 and 1111, whatever may be the value, change all ones to zeros, complement the mask, and ORing bit by bit with the given address will provide you the last address. Just perform the simple calculations. You will get the first address as well as the last address in the entire range of data. Entire range of IP addresses for class A, for class B. The restrictions can be applied to the block. The addresses and the mask actually provides us the classless inter-domain routing. Classless inter-domain routing. That means at the network layer, the two networks will communicate only if they are permitted from one class to another class. For a subdomain also. That's why it's quite difficult to access a terminal in mechanical department from a terminal that's available in our electronics department. If all are in the class B, then it's quite easy to share the data in between the mechanical terminals and the electronics terminals. I think this particular concept just digest. If there are any difficulties, just tell me the difficulties. The number of addresses can be found by complementing the mask, interpreting it as a decimal number and adding 1 to it. That will be the number of. Just take an example. 255.255.255.240. How many addresses will be there? Just calculate it. 255.255.255.240. This is the mask. 255.255.255.240. Represent 240 in the binary format. Take a complement of the mask entirely. Then convert that into a decimal address and just add 1 to it. That will give you. Yes, for try it for 255.255.255.240. how many addresses will be there in the network? So the mask will be 1111111111. All first 3 bytes will be all ones and represent 240. What is the representation of 240 into binary? Type in chat box. Correct, Pooja. It's 11110000. So take a complement of the mask now. It will be 00000. First 3 bytes will be all zeros, and last byte will be take a complement. So it will be 00001111. So 8421. 8421 is 15. Add 1 to it. It will be 60. That's how the number of addresses can be found out. Correct. That's how we are defining, or we are limiting the number of addresses or number of host IDs in a specified network. If only 16 are permitted, if 17th terminal is connected, only 16 will be part of the network, 17th will not at all be part of the network. That is the meaning of the mask that is being assigned to the IP addresses. Only 16 addresses are permitted within that particular subnet. If 17th terminal is added, you have to change the mask. Then only that terminal will be allowed in the data terminal. There are again hierarchies that are associated with the IP version 4. Area code, exchange office, subscriber. Nowadays, we are not at all utilizing this configuration, hierarchical configuration. It's just 28 bits and 4 bits, network prefix and host addresses that we are utilizing. Prefix and addresses. So one particular subnet will have IP addresses in the range 17.12.14.31, 14.30, 14.20, from 14.1, having the specific subnet mask of /27, which will give you the number of IP addresses. From 27, it will be connected to the router. The next IP addresses will be available for this. For this will be the second network. This will be the third subnet. See here, 12.14.63. From 49 to 63 it will be subnet 3. From 33 to 47 it will be subnet 2. The locations may be entirely different. The three different subnets may be connected with the support of this router. So this subnet 1, we can call it as the electronics department, then mechanical department, electrical department for one particular organization. If the specified range is to be assigned 17.12.14.31, 17, that means it's a class A type of configuration. So the subnet mask that will be assigned will be 255.255.0.0.0. If it's class A, subnet mask will be 255.0.0.0. If it's class B, subnet mask will be 255.255.0.0. If it's class C, it's 255.255.255.0. That is the subnet mask configured for the subnetwork. You can assign your own hierarchy for the IP address nomenclature, but you have to remember that by providing this particular IP address nomenclature, you are actually assigning the virtual address. So the virtual address should be also a correct address, then only the packet will be properly delivered. Make it very clear. The packet will be very delivered. Just go through this particular example 19.10 from version. You can try it. You can try it for your own configuration. It's one of the example addresses for a private network. If the IP address starts with 10.0.0.0 to 10.255.255.255, then almost 2 raised to 24 computers can be part of that particular private network. If it's 192.168.0.0 to 192.168.255.255, see the last combinations, 255.255. So it's 2 raised to 2 into 8, that is 2 raised to 16. So 2 raised to 16 IP addresses. If it's the 192.168.0.0, the 192. Say 192.168.0.0 to 192.168.0.255. Then it will be only 2 raised to 8. So 2 raised to 8 is 256. So only 2 raised to 8 addresses will be available for that particular class C type of private network. Those will be the internal IP addresses which will be connected to the internet with a public domain IP address which is allocated by the internet service provider. And that's what the class type of configuration that we are utilizing in our organization. The range of IP addresses that are assigned to our all the data terminals in the campus are the private IP addresses which are able to connect to the external network with the help of public IP addresses which our service provider Railtel and BSNL are allocating us. So the firewall that is used in our organization is assigned with the public domain IP address so that all our requests to the external network will go through the firewall to that external IP address which is allocated to all the group of all our terminals. So from the campus, whenever if you try what is my IP, for all terminals you will get a single IP address. That is a public domain IP address which is allocated to our all data terminals in the entire campus, whatever may be the class of IP addresses that are utilized. Typically in our campus, the IP address class B type of IP address scheming is used, 172.16. .0.02.255.255. These are the number of IP addresses that can be utilized in our entire campus. That is the class B type of IP addressing scheme. But if you want to restrict, then you can utilize class C type of IP addressing scheme also. But in our campus, the IP addresses for the terminal starts with 172. That's a class B type of IP addresses that are assigned. This is the typical example. These are all the private IP addresses. These are the IP addresses which are assigned to our sub network. Internet service provider is providing us a public domain IP address. So all these IP addresses, internal IP address, will utilize one single public domain IP address, that is 200.24.5.8, and then only it will be getting connected to the internet. If this IP address is not assigned, then you are not part of the internet. It's only a local area network, not connected to the internet. So internal networking is also possible with the support of this class B type of IP address. That's how one specific terminal is communicating with internet. But all these terminals will be allocated a same IP address, external IP address 200.24.5.8. The packets will be again available, but whoever terminal request that is maintained in this either a router or layer 3 switch, so that the packet for this IP address which is destined for this internal IP address is separated at this router or at this concentrator or at this layer 3 switch, and that packet will be delivered to the specified address. That's how the terminals communicate with internet. It's again another example. Private IP addresses and external IP addresses. Specifically for our organizations, 8 IP addresses in the public domain are allocated by Railtel. 8 public domain IP addresses are allocated by BSNL. So we have 16 public domain IP addresses through which we can communicate with the extra. And in our entire campus, almost there are 800 to 1000 terminals, along with the wireless devices such as your mobile. Those are also available. So all those devices will be allocated the internal IP address, which will communicate with the external world with the support of the public domain IP address which is allocated. So are there any difficulties? I think today we'll stop here only. We'll continue same in our coming lectures. If there are any difficulties, you can turn on your mic. You are going to be a software developer, this particular concept of IP addressing must be very, very clear to you. If you are going in a web programming or socket programming domain. If there are no difficulties, if we stop here, just type it in chat box. We have one practical remaining, that too again the IP address allocation. We'll take that particular practical in the next week, not in this week. Routing. Till that the concept associated with will be clear. And next time in the next practice, today there will no be practical in this week for all the batches. Next week we will see the routing that is being associated. This routing we can clear our concept how these terminals communicate with the external network, how actually the shortest path is found. That will be our last practical. Along with that, I will also go for software, open source software, Wireshark. In the meantime, you can download that Wireshark software. This Wireshark software will help us in analyzing what are the contents in the packet. So try to download that Wireshark software. Will not take any practical in this week. Try to install it on some terminals. Then we'll go for the details analysis associated with the packet. Unless and until you get this particular concept of IP address, the concept of packets, the packetization, the practical of Wireshark is not also fruitful practical. That's why this week also will not take that. But in the next week, we'll see Wireshark as well as the routing practical. No practical in this week for CCN. Are there any difficulties? If no, just type the message no. That will be your attendance. So it will be attendance for those. Recording of this will be available on YouTube channel. Subscribe my channel so that you will get the notification of whenever I upload the video. All the links. Also join the Moodle where we will be conducting our class test 1 and class test 2. Within a short span, you will be giving the class test 1 and class test 2 on the Moodle platform. A practice test either I will take in the next week for Moodle on Moodle, but you will get a feeling of how the test will be conducted. Class test 1 will be conducted for our CCN. Most of the we'll be finishing our entire syllabus in the next 10 lectures. Your test 1 and test 2 will be on Moodle platform. I think all of you have the IP address. Then join the Moodle network by this IP address that I am sharing in the chat box. Go to this IP address, check whether you are member. If not, be a member. If there are problems, communicate with Professor Tanurkar madam for your activation of your account on Moodle, on which we are going to conduct our class test 1 and 2. and it will end just